Hi, and welcome to Calculus Examples. I'm Dr. Finch. Today we're looking at the area of a region bounded above by y is equal to e to the x, below by y is equal to x, and on both sides by x is equal to 0 and 1. So when we're finding the area of a region and we have more than one equation, a lot of times the first thing to do is to draw that thing out. I love this because I'm a very visual person. I find a lot of students are very visual as well. So drawing out our picture of what we're looking at can be super helpful. E to the x has this nice little shape here. Our line y is equal to x, we know goes through the origin of our graph, so we can pop that in. And we notice that we're bounded on both sides by x is equal to 0 and x is equal to 1. So I'm going to put 1 in there. I'm going to put dots just to indicate that's where we are, and I'll shade in that's the area that we're looking for. When we're finding the area of a shape that is bounded by multiple regions, we want to take the top curve and subtract from it the bottom curve, right? And then dx on the backside. The reason for this is when you take the integral of the top curve, you're getting everything all the way down to the line x is equal to 0. Or y is equal to 0. And then when we subtract the bottom curve, we're basically cutting out that little bit that's under our second curve, our y is equal to x, which leaves us with this nice area that we're looking for. And if you enjoy explanations like this, subscribe. I am doing Calc 2 problems all spring. All right, let's get into our area. We are going to write this out as an integral. Notice our bounds, we're given that, so we know we're going from 0 to 1. So that's going to be our bounds on this. Our top curve is e to the x, and our bottom curve is x. And we are doing this with respect to dx. To integrate this, the antiderivative of e to the x is e to the x. For the antiderivative of x, we add 1 to our exponent, divide out by our new exponent, and we are evaluating this from 0 to 1. So let's start out by punching 1 in everywhere we see an x. And I love parentheses here. I'm a big stickler for that because it helps us in so many different ways when we use our parentheses properly. In particular, it helps us deal with things like our minus sign does need to be distributed. In this case, it really doesn't matter because our second term here is going to disappear, but in general, you do have to be careful about all those things popping up. E to the 1 is just e. E to the 0, this is the one number of e that you actually should know is e to the 0 is actually 1. So e minus 1/2 minus 1. So this gives us e minus 3/2. And we are not going to simplify this any further. This is the solution to the area between those two curves. Thank you for listening.